Today we're at the NOAA ship Shimada. It's part of a NOAA fleet that does science offshore. We're with the Monterey Bay National Marine Sanctuary. We have a lot of collaborators with us from Stanford University, from Moss Landing Marine Labs, from the National Marine Fisheries Service, from the University of California at Santa Cruz and others. And we're out to explore the Davidson Sea Mount. We know that that area of the ocean is spectacular for its deep sea creatures, but we have less information on the birds and mammals and almost no information on the midwater fishes. So we're going to be comparing different ways of studying marine mammals with standard visual observations, with an unmanned aerial system, a small plane, with hydrophones, and see what small fishes live in this area that we know that the mammals might be congregating to feed on. But we're also taking water samples in developing this new technique called environmental DNA. So we collect loose DNA that's in water samples and describe what's in the ocean, not based on what we're seeing in nets or from standard observations, but from DNA samples left by organisms that were swimming by. So here we are underway above the Davidson Sea Mount, and we've already the crew has solved several of our problems in setting up our gear already, and the scientists are excited to be using all of their skills, all the things that they've learned to help us study, better understand the oceans so we can better manage and protect it. So when we're talking about bird and mammal observations, at the highest point of the ship we have a string of scientists that are looking out to sea. Some of them are using large binoculars, some of them are using smaller binoculars, and we have experts in marine mammals, we have experts in seabirds, and they're calling out what they're seeing. And as they call it out, there's another scientist typing it into the computer, so we have the species that's seen, the distance from the ship, and the location of where the ship is. We're also using hydrophones during this cruise. With new technologies, there's different ways of studying the ocean, and each technology has its advantages and disadvantages. When the weather is rough and you can't see the birds and mammals, you still can hear them by releasing a hydrophone into the water, and it's floating out there at sea, and it's picking up the sounds of what is happening underneath the water. It's been a bit challenging releasing the hydrophones in this rough weather and picking them up. But with a nice ship like the Bell Shimada and a really a crack crew, we were able to pull that off. And the data is coming in really nicely. The way we collect the water is with a more standard oceanographic equipment called a CTD, Conductivity, Temperature and Depth Profiler. And it goes on a winch down deep thousands of feet, and on its way down or on its way back we can send a message to close off these bottles that take samples of water at different depths. So we've been collecting hundreds of pounds of water off of our CTD and effectively brought it on board to start filtering the samples.
Hello, I'm Commander Brian Parker. I'm the commanding officer for the Bell Shimada, speaking to you from the bridge of the Bell Shimada. We're the fourth in the series of 5 of fisheries survey vessels that were built for NOAA. The vessel specializes in fisheries research. She primarily uses acoustics to determine biomass that's underneath the ship. This is kind of a change from strictly using the trawls, and creates less of an effect on the fisheries populations. When we're on a project, the ship CO is in charge of the ship and in charge of all safety operations. The chief scientist is in charge of the operations for the scientists, the data collection. And the two work in pretty much a partnership to ensure that we're safely collecting as much data as what the scientists are required.
We've had an exciting and exhausting cruise. People have been working day and night for a few weeks now, and the data is already looking interesting, preliminary, but we're looking forward to sharing it with the public in scientific papers. And that's our role as sanctuary scientists, to monitor the resources within the sanctuary and to assess the health of the sanctuary. Because we want to make the right decisions, give the right information to managers to help them make the right decisions, to give information to the educators to inform the public, so that we can ensure a healthy ocean for the many generations to come.